Today's video is going to discuss adding and subtracting radicals. Yesterday we talked about how to simplify radicals, and this is just going to be like simplifying radicals and then combining like terms. We just kind of have to relearn the definition of like terms to define common radicals. And that was supposed to be a square, my bad. So the directions it gives us are to simplify all radicals, then identify radicals with the same index and same radicand. Only these can be combined. And then add or subtract the coefficients and keep the common radical. It's going to make a lot more sense when we practice it. So let's just jump right in, okay? We want to simplify all radicals. So let's just take these as totally separate things, okay? So we are going to bring over 3 square root of 27 and do that individually. 3 square root of 27, we are going to break this down into 3 times the square root of 9 times the square root of 3 because 9 is the largest perfect square that goes evenly into 27. And then that is going to reduce to be 3 times the square root of 3. And 3 times 3 is 9. So completely simplified, this is 9 square root of 3. So that's what goes here. We bring down the operation, and then we're going to take care of 2 square root of 12. So 2 square root of 12 can be broken down into 2 times the square root of 4 times the square root of 3 because 4 is the largest perfect square that goes evenly into 12. And it goes into 12 3 times. This will reduce to 2 times the square root of 3. And 2 times 2 is 4. So completely simplified, this is going to equal 4 square root of 3. So we put that in place of 2 square root of 12. This is our new expression. And so we've simplified all radicals. Then it asks us to identify radicals with the same index and same radicand. Only these can be combined. So that means that they both have to be square roots or cube roots or fourth roots, but they have to be the same. And then everything under the radical also has to match. So you almost treat the radical like it's a variable. It has to be, in order to combine x's, they have to both be x's. So in order to combine radicals, they have to be the same radical. So we add or subtract the coefficients and keep the common radical. So 9 minus 4 is 5, and we keep the square root of 3. So think of it, we had 9 oranges. Say that's what the square root of 3 represents. And we subtracted 4 oranges, we have 5 oranges left. Anytime we talk about like terms, I like to compare it to fruit. I've only got a couple examples of these to work out because once you understand what the like terms are, you've already been practicing simplifying radicals. So I think that this should come pretty easily to you. Hopefully, that's the idea. But first, we have to take each radical and reduce it. So I decided to color code it some so that you can kind of follow along. So the first radical we have is 7 fourth root of 48. 7 times the fourth root of 48. So remember, anytime that you have radicals, you can and probably should recreate the list of those perfect radicals. So like this is a fourth root. So our list of perfect fourths was 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, and so on and so forth. So I'm actually thinking about this, and I know that 81 is bigger than 48, so we don't need any numbers bigger than that for this particular instance. But you can list those anytime that you have to work with radicals, and it does make a difference. It makes it a little easier. So we know that 16 is the biggest perfect fourth that goes into 48 evenly. So we are going to break this down into 7 times the fourth root of 16 times the fourth root of 3, because 48 divided by 16 is 3. Then this is going to simplify to be 7 times the fourth root of 16 equals 2. And then the fourth root of 3 can't be reduced, so it stays as it is. And then 7 times 2 is 14, so the final version of this is 14. Oh, I need to write better. 14 times the fourth root of 3. So that's what we're going to put back over here where this radical was. 14 times the fourth root of 3. Then we need to take care of the next one. Remember that we always bring down our signs. So like this -2, we're just going to keep it here. And then we're going to simplify the middle radical. And actually, now that I'm paying attention to what I'm saying, the fourth root of 3 cannot be simplified because 3 is not divisible by any perfect fourths except for 1. But if we divide 3 by 1, we still have 3. So we're just going to keep repeating that forever and ever, and it's not going to change anything. So we can just bring it down as is, 2 fourth root of 3. Then we need to look at the final one. So we have a plus here from there. And we have 3 cube root of 72. So 72 is a not tiny number, so we need to check it and make sure that it's not divisible by anything. So 3 cube root of 72. Notice this is a cube root. It is very important that you pay attention to that index. It is going to change everything. Numbers mean everything in math, obviously. So we can't use this list anymore. We have to use the perfect cubes list. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. 5 cubed is 125. And look, that's as far as we need to go because 125 is bigger than 72. So we can stop there. The biggest one of these numbers that goes into 72 evenly is 8. So we will break this down into 3 times the cube root of 8 times the cube root of 9 because 72 divided by 8 is 9. Now keep in mind, this is a little bit confusing because you see a 3 and a 9, and we know that the square root of 9 equals 3. And so our brain really wants this to work. But 9 is not a perfect cube, and it is not divisible by any other perfect cubes. So this cannot be reduced at all. But it's tricky, and it's something that your brain really wants to think that it'll work. But it doesn't. So make sure you're paying attention to details when you do this. So when we simplify another step, we're going to get 3 times the cube root of 8 equals 2 times the cube root of 9. 3 times 2 is 6 times the cube root of 9, which is just 6 cube root of 9. Okay? And I hate this because, 6, 3, and 9, like those are related numbers. They're friends. And, they're all multiples of 3. 3 plus 6 is 9. The square root of 9 is 3. Like there's all these relationships, but this number can't be reduced. That is what it is. So that's what we're putting in up here. 6 cube root of 9. So we've simplified all the radicals. Now we are going to go through and combine like terms. Let's see here. Remember that the only radicals you can combine have to have the same index and the same radicand. So notice that we have a 4, a 4, and a 3. So automatically this guy cannot be combined with the others. Now we have a 3 and a 3. So yes, these two can be combined, and when we combine them, we add or subtract the coefficients. So 14 minus 2 is 12, and we keep the radical the same, the fourth root of 3. And then we just tack on this because it cannot be combined. And our final answer is 12 times the fourth root of 3 plus 6 cube root of 9. All right, last example, number 5. The square root of 98x to the fourth, y squared minus 3x squared, y square root of 2. It's a lot of stuff to say. So let's just start one radical at a time and reduce them. So square root of 98x to the fourth, y squared. And if you remember from our last video, I told you the easiest thing to do is to break this into different pieces. So square root of 98 times the square root of x to the fourth times the square root of y squared. So the square root of 98, we're going to break that down into the square root of 49 times the square root of 2. And then the square root of 49 is 7. So we're going to get 7 square root of 2. Then the square root of x to the fourth, remember we do 4 divided by 2. There's an understood 2 there. 4 divided by 2 is 2 with none left over. So since 4 divided by 2 is 2, we get x squared, x to the second power. And then the square root of y squared, 2 divided by 2 is 1 with none left over. So that's going to get rid of the radical. 2 divided by 2 is 1, so it's y to the first power, but that 1 is unnecessary. Don't have to write it. And then once we get everything simplified, we take everything outside the radical and multiply it together. 7x squared y. And then everything inside the radical, but there's only one thing here. So that's a 2, not a z. So the first term is 7x squared y radical 2. And then we bring down our subtraction from here. And we don't even need to simplify the second part because the square root of 2 is already simplified. So that radical does not need simplified. So I'm just going to bring it down. We get minus 3x squared y radical 2. Now, it tells us that they have to have the same index and same radicand in order to combine like terms. We have the square root of 2 in both places. But in this case, our coefficients also have variables in them. So we also have to make sure that the coefficients are like terms to each other. So we can only subtract these if the variables and their exponents are the same. And in fact, x squared y and x squared y are the same thing. So we have the same radical, the same exponents, variables with exponents. And that means we can subtract. So we're going to do 7 minus 3, which is 4. And then all of this stays the same. X squared y square root of 2. And that's your answer. All right, that's it. Have a great day.